Hi everyone, can you hear me well? I guess so. Good, good. Thank you for coming here. I'm Štěpán. I work in the Oracle Labs and on the GraalVM team, and today I'm going to talk about GraalVM scripting languages, the changes that we've made to them in the latest release, and in particular I'm going to talk about the Python GraalVM-based Python implementation and how you can enrich your Java applications with it. Slidos, ask questions. I'll try to remember to check the questions during the talk. So let's start with the introduction. What is GraalVM? These days, people usually use the term GraalVM as a synonym for the GraalVM native image tool, which is fine. That's probably the most popular, the most used, the most well-known tool from the GraalVM project, from the GraalVM umbrella. But GraalVM really is a set of multiple technologies, and all of them revolve around something that we call a GraalVM compiler, which is a compiler that takes Java bytecode as an input and spits out native machine code. This GraalVM compiler can be used as a replacement for the C2 server compiler in the HotSpot JVM. This is something we call the GraalVM JIT mode. Then it can be used by native image for ahead-of-time compilation. That's probably the most well-known use case. But today we're going to focus, or in this talk, we're going to focus on the third use case, and that's using the GraalVM compiler to compile other alternative languages on JVM. And we have a framework for that that's called the Truffle framework. The idea is to reuse the JVM infrastructure, which is advanced VM that's been developed for tens of years, thousands of engineer days spent on developing this VM. We also have native image, which you can think about as another advanced JVM implementation. And well, we want to reuse all that work and run, say, Python or JavaScript on top of that and reuse the garbage collector and everything. You could say, okay, if I want to reuse JVM for another language, I can just compile that language to Java bytecodes and run that on the JVM. But you really need to design a language for that. And semantics of languages that were not designed to run on JVM usually don't match or don't map well to JVM bytecodes. So we have this framework, whose input is actually interpreter written in Java, and then it does something called partial evaluation to actually compile that interpreter to deliver just-in-time compiler for that specific language. I'm not going to go into any more details here. There are some things that you can find on the internet, even some talks by me in previous GeeCONs where I explain this in more details. Today I'm going to focus on the practical side of things. Languages built on Truffle are, for example, GraalPy, which is a Python 3 compatible implementation that we are building in-house in Oracle Labs. GraalJS, JavaScript, the same story, the same for Truffle Ruby and a few other languages. There are also community developed languages. For example, Enzo, which was, there was a talk about Enzo yesterday. So why this polyglot thing? Why additional languages on top of JVM? Because of this advanced VM technology that we are reusing from JVM, we can deliver very good performance. We are on average 3.5x times faster than the reference implementation of Python on PyPerformance benchmark suite, which is a benchmark suite that the Python itself uses to benchmark itself. It's not a benchmark suite that we would tailor for us. If we take a look at some more specific benchmarks, for example, GC-heavy benchmarks where we can really shine thanks to the advanced GCs that we can reuse from JVM, we can be almost orders of magnitude faster. Another reason for all this is integration with the JVM ecosystem, and that's why we are over here, right? You can embed scripting languages into your Java applications, basically use them as a library. You can access Java from those languages, and you can access those languages or their objects from Java. This whole thing supports GraalVM native image, so if you use these libraries, these languages in your Java application, you can compile your Java application to native image, standalone, executable, and it will just work. By the way, the languages in that case will still be just-in-time compiled when they run on the native image. So the just-in-time compilation will apply only to the Java sources around, but the language, those languages themselves, they will be just dynamically just-in-time compiled. There are lots of tools for JVM. I don't probably have to tell you about that. There are multiple GCs, you can tune them. All these things are usually not available in the, are not as advanced in the other ecosystems, I would say. So now let's take a look at how to use the GraalVM polyglot capabilities and how it changed from the previous version. In case you've used the previous version, or in case maybe someone watching the recording later used the previous version, we have in the version 23.0 GraalVM version and previous versions, what you would do is that you would download the GraalVM distribution, which would just contain JDK distribution and the GraalVM compiler, and then you would install additional components using this thing that we called GraalVM updater, GU. So you would call GU install Python or GU install native image, for example. There were issues with that. By doing this, you were basically mutating the installation of the JDK, which is not a common thing, and some tools are and some systems are not happy about that. Also, this GU thing is like our it's not proprietary because it's open source, but it's our thing that no other tools understand and can use. So, welcome to GraalVM for JDK 21, which is the latest release of GraalVM, where we changed those things significantly. First of all, GraalVM for JDK 21 is a JDK distribution that contains the compiler, the GraalVM compiler, and native image. And you don't have to install anything else on top of that if this is just what you want. You can think about it as another OpenJDK distribution, like Amazon Corretto or whatever. The GraalVM operator thing, that's gone. That's removed without replacement. There is an ongoing project called Galahad, where we would like to move applicable portions of the GraalVM Java technology, upstream those to OpenJDK. So that would be initially the GraalVM compiler and maybe eventually the native image, at which point the GraalVM JDK and OpenJDK would eventually be equal. There are two distributions. There's Oracle GraalVM distribution, which is based on the OracleJDK. It has some additional proprietary optimizations, and it's licensed with this GraalVM free terms and conditions license. I'm not a lawyer, but the intention of the license is that you can use it for commercial purposes for free. There is an alternative, which is the GraalVM Community Edition, that's built only from open source code, and it's licensed with GPL2 with ClassPass exception, I think, which should be the same as OpenJDK. GraalVM is available in SDK man. You can install it with SDK install Java 21-Graal. So, truffle languages. So we have GraalVM JDK distributions. Where do the truffle languages go? We unchained them. The code name for the project was Truffle Unchained. It was mentioned yesterday also in the Enzo talk. We unchained the truffle languages from the GraalVM JDK, and we have two distribution channels for those languages. Either you can download a self-contained native distribution of that language, so that would work as kind of a drop-in replacement for the reference for the standard implementation of the language. So you can download a standalone self-contained GraalPy distribution. That would be an archive. You uncompress it on your disk, and you can use it as a Python. The other distribution channel is Maven Central. So we package those languages into Maven Central artifacts. The difference from the previous versions is that Not only you can use them on the GraalVM JDK, but they are now supported on other JDKs from 21 upwards, so OracleJDK, OpenJDK. And this distribution channel is meant for using those truffle languages as libraries in Java applications, which we think is much more natural a way of managing your dependencies in Java projects than the previous approach with Graal Updater tool. There are also Oracle and community variants in both cases, for the self-contained native distribution and for the Java libraries distribution. Some of the licenses might differ slightly. It depends on the language itself, how the language itself is licensed. But we use permissive licenses where possible. The latest release is 23.1.1. I'm not sure if it's published, but will be published soon. It might be 23.1.0 now. And those languages follow the previous GraalVM versioning. So we have GraalVM for JDK 21. We will have GraalVM for JDK 22 when JDK 22 is released, etc. But the languages follow the GraalVM versioning. But for the time being, we plan to release them together with the GraalVM. So how the self-contained distribution looks like, you either download it, unpack it on your drive and run it, or usually you would use technologies that are native to that specific language ecosystem. So in Python, they have something that they call Conda, Conda Forge, from which you can download various Python implementations, and you can download precompiled Python packages, things like that. Or there is PyEnv, which is something like SDKman for Java. So that's how we use the self-contained distribution if you are a Python developer and you don't really care about Java. But this is not for us. We are here for the JVM stuff. So this is how you would use this in Java as a library. So you declare dependency on something we call a polyglot API, which is the API that you are actually going to use. So on the right-hand side, you can see the usage of that API. And then you can declare dependency on additional languages. Those languages don't expose, or usually don't expose, any API by themselves. You're supposed to use them through the polyglot API. But you can think about them as service providers. So they provide this Python artifact is going to provide an implementation for a Python language that you can use through the polyglot API. The languages that we exposed this way are JavaScript, Python, Ruby, LLVM, WebAssembly. If you append -community, you're going to get the community version. And there is some support for sandboxing through isolation, through the native image isolation feature. I'm not going into details, but you can find some more details in the documentation. This is useful if you really want to isolate the execution of that scripting language from the surrounding environment for security purposes. Also, before this API that is on the right-hand side, before that it was published also on Maven, but just for the convenience. You couldn't really run it. It was just so that the IDEs can, for example, show you the completions and stuff. And this was in OracleJDK, Graal SDK artifact. This is now deprecated. It's still published for 23.1.0 and so on, but it's deprecated. And this thing contained not only the polyglot embedding APIs, but also the native image APIs and a few other APIs. So we decided to refactor that and split that into several artifacts. So there is one for native image and one for polyglot embedding, and new are the artifacts for the languages. What about backwards compatibility? The idea is that for we are going to maintain compatibility with the Java LTS versions. So the languages and the polyglot API will continue to work on Java 21 up until Java 25, which should be the next LTS. And then also along the way, we get support for the current non-LTS Java versions. So if the current Java version is 23, for example, these polyglot artifacts will work on 23 and 21. There are some caveats for when you use non-GraalVM JDKs. The thing is that the non-GraalVM JDKs don't contain the GraalVM compiler out of the box. So we can't really do the just-in-time compilation that's powered by the GraalVM compiler. So there is a significant performance impact. It might not be such an issue for your use case. Depends on the use case. It prints a warning so that people don't come back to us telling us how slow our interpreters are without actually realizing that they're not running in the most performant mode. But you can suppress that warning. The GraalVM compiler can be also pulled from Maven so that you can use it in other JDKs, but that requires experimental VM option, enable JVM CI. So shouldn't be used in production, right? And requires adding the compiler jars to upgrade module path. Now let's take a look at some examples. So this is a simple Maven-based Java project. If I run it, it says hello world. What I'm doing here is that I added the dependency to GraalVM polyglot and the Python language. And now I'm going to use the context API. So how is that used? There is this class context. You can create a new context. You can restrict the languages, but I'm not going to do that. And this thing is closable, so we're going to use a try block for that. And this context gives us this eval function to which we can send the name of a language that we want to evaluate and some code in that language that we want to evaluate. Now, because we're executing a string, basically, we don't know what this is going to return to us, right? So there is this value class that represents any value retrieved from a dynamic language. And we can ask it whether it fits in int, for example. Or we can get the int value if we think it does fit in int. Let's run this and hope it's working. It does work. Well, nice. So we are creating here this context. One useful feature maybe is that you can create another one, like this. And those two contexts should be isolated. So if I say a equals 42, and then I'm going to say context eval Python print a, that should print 42. But then in the other context, if I say print a, that should tell me that a is not defined. Let's hope it actually works. Okay, so it says name a is not defined, but before that we printed it. That's the print from this context. So you can have multiple contexts. They are isolated. They don't see each other. So that's that. What did we want to show? Okay, so I forgot to switch my JDK. So we were running on the GraalVM JDK now. I'm going to switch to just plain JDK 21. I think it's OpenJDK. When I run the thing, it still runs, but it tells me that the polyglot engine uses fallback runtime that does not support runtime compilation. And it also tells me how to suppress this warning. But the good thing is that it still works. Multiple isolated contexts, we've seen that. Oh, so let's try something more interesting. I'm going to use the text block feature here. hopefully this is going to work. And I'm going to define a function called sum. It's going to take something called r, start and end. So that's a Python function here. I'm going to, as you might guess, sum the things in the array like this. And we're going to return the result. Not sure what the IDE did here. Okay. So when we evaluate that thing, we're gonna get a module, Python module. And in that module, we can look up via get member the function sum. We can execute it, and we can give it integer array 1, 2, 3. We want to sum from the first 2 elements, and I'm going to print the result. Let's see what happens. Unexpected indent. Oh my god, what did the IDE do here? That's Python, yes. Good. Foreign object is not subscriptable. Wow, that's bad. So Steve, you just told us that you can use Java objects from Python and it's not working here. What's the problem here? So the issue is that the contexts are by default restricted in what they can do and how they can interact with the host Java system. So what we really need to do is we need to use the builder to create a context that allows host access. And we can even further configure the host access, but I'm just going to say host access all. I'm going to build this thing. And now the Python code can access the array and it can actually look at the values in it. So we have this sum function that we executed and it all worked. Now I'm going to cheat here and copy paste the code that creates a random array with lots of elements in it. And I'm going to run a loop, I don't know, 100 times. I'm going to take this sum function, put it here, and I'm going to execute it with that array in a loop. And so, what do we want to execute? Data and data length. And we're going to do something like this: system nanotime, start, and we're going to print how much time it took. So what we want, end minus start, and let's make it milliseconds. Okay, so let's run this. So we can see it takes a while. There was some warm-up, but we're running without a just-in-time compilation. So let's see if we switch back to GraalVM for JDK, how this is going to change. We're not getting the warning, and we got much faster. So before it was something like 250, now it's around 60 seconds. And to actually prove that the just-in-time compilation is taking place, I'm going to add an option, engine trace compilation. I'm going to say true. And if we run this now, we can see that things are being compiled. So when the Python starts, it actually executes significant portion of Python code. So that's the compilations here. And here we can see that the optimization of the sum function was done. It's much faster. But at some point, no. Yeah. When I was trying it before the presentation, it de-optimized and re-optimized again. Now it doesn't want to do it for some reason, but I guess that's even better. So, yes, and I wanted to show how to build a native image of that. Where am I? Nice. So what do I want? I want to package this thing. But I need to use, so in this case, I actually need to use the, Graal JDK because I want to use the native image. So I'm going to package this thing. Hopefully it will start compiling the native image. It does. So the thing is that now we are not only compiling our hello world example, but we are also compiling the whole Python interpreter with it together. So it's going to take a while. I'm going to switch back to the presentation and continue with it and let it run in the background. So I'm going to talk a bit more about GraalPy now. It's an alternative implementation of the Python 3 runtime. It's quite compatible. It passes most of the relevant C Python tests. It supports Python native extensions, things like NumPy, Pandas, Matplotlib. As we've seen, it supports multiple independent executions contexts in one VM process. It's fast. Of course, there are some caveats. It's not 100% compatible. I think it's quite close for pure Python code. It's a bit farther with native extensions, but we're working on that. And as a data point, I think it's much more compatible than JIT ever was. I think it's probably as compatible as PyPy or maybe more. But that's all my educated guess. The performance of native extensions, well, we're using JNI or Panama under the hood to do the native extensions, to run the native extensions and communicate with them. And as you might be aware, there's some overhead with this approach, but we're working on removing that as much as possible. Also, if we run native extensions really natively as a native code, there is no isolation. We have this option to run the native extensions on the GraalVM LLVM interpreter, which interprets LLVM bit code on the JVM, and that provides some level of isolation. But that has a much larger startup and memory footprint than executing the native code. So there is a trade-off. There's this website where you can check the compatibility with the packages Python packages that you are using. You should take this with a grain of salt because, I mean, there might be a package that has 10 tests. We pass all of them, but the tests don't really cover that package. There might be a package that has 5,000 tests, and we pass 80% of them. And we are actually quite good there. And we're not passing some weird corner cases that are not really that relevant for your use case, maybe. So you can use GraalPy as a JIT replacement if you used JIT before. The thing is that JIT, the production version of JIT was for Python 2.7. There is a branch for Python 3, but I don't think it reached any sort of stability. So GraalPy provides some JIT language features to ease the migration from JIT to GraalPy. Some of the features can negatively impact the performance, so you have to enable them with these options. So this is when you are using Java from Python, using the JIT approach to that. If you want to embed Python in Java, JIT had its own API for that. We don't support that. The sort of the preferred or the recommended approach is to migrate the usages to the Polyglot API that I've just shown. There is also example implementation of the script engine, JSR 223, for GraalPython. We don't recommend it for let's say, production use. We recommend it for quick evaluation. When you're using JIT through this script engine, then you can easily switch to GraalPy and evaluate. But eventually, we recommend to migrate to Polyglot API. There's this tool that we... this video is not going to run, unfortunately. But there is this tool that you can use to... you can think about it kind of like native image for Python. You can package a Python application with all its dependencies into a self-contained native executable that you can just take to another system and run it. And if the video was playing, that's a game written in Python using this Pygame package. And with this command, we could package it into one executable. So we think it's a neat way how to distribute Python applications. But again, we are not Python developers here, right? We are JVM developers. This tool can also generate a skeleton for a Java application that is embedding Python. And it provides some scaffolding for packaging the Python dependencies into the jar as resources. So what you get out of this is a, let's call it self-contained jar with the Python application and all its dependencies. So that's maybe one option how to deploy Python applications on a server where you already have Java or GraalVM. And it can be a starting point if you want to develop an application that is leveraging the GraalPy. What we are thinking about doing next is a Maven plugin to manage the Python dependencies. So this tool generates a POM XML that contains all the code for managing the dependencies. So it's like 300 lines of XML. We would like to wrap all that into a nice plugin that will give you a seamless interface for managing Python dependencies. This tool is actually driven by GraalPy. It's a Python package. We would like to turn that into a Maven archetype, which we think will be more natural for Java developers than running Python. And we are also working on a tool to generate Java interfaces for Python libraries. So you could use NumPy or Matplotlib from Java by using Java classes or interfaces, and they will, under the hood, delegate to the Python runtime. So I have a demo with more practical demos with Micronaut. So let's take a look at what the native image did. Okay, so it actually generated something. Let's take a look at that. It's running and it's doing something. And we can see that even though, let me prove that, even though that it's a native image produced by the native image tool, it still is doing just-in-time compilation of the Python code. So here we compile the sum function and it got faster. So let's take a look at another example. Let's see if it actually works. So this is a Micronaut application with a UI that I developed. So there is a like in-memory fake database with some books, and the idea is that here we have like a text area where we can write Python code to filter what we see here. So we can do something like book name starts with T. And it works. It shows us books that start with T. But maybe we don't like that it shows us books that start with the, right? Because that's not really a start of a word. So we can say, note book name starts with the. Good. So we have that. We might not like that there are duplicates, right? I don't like that. So we're going to create a set here. And we're going to say if book name is in S, then return false. And S at book name. Now fingers crossed that I didn't make any syntax error. it works as well. So let's take a look at the actual implementation. So there is this books controller that uses books repository. And books repository, there is an in-memory implementation for that. That's a detail, but we are getting context injected as well. So there's the polyglot context that I was showing earlier. And I have this polyglot context factories thing where I tell Micronaut how to create the context bean. Now in this controller action, we're getting all the books, and then we are looking whether the user sent us a Python filter. And if the user sent us Python filter, we're actually we're going to evaluate that code. We're going to find a function called filter in that code. And if it's there, we are going to execute it. So here we are using streams. So this result thing is a stream of books. We're going to filter, and in the filter lambda, we're going to execute the Python function. We're going to assume that the Python function returns a Boolean, so we're going to hard cast it to Boolean. In more real-world code, you would probably want to check whether it's Boolean and then actually cast it, and maybe have some error handling there. And to this filter function, we send the Java object that represents the book. And here I can just access book name, which is a field of the Java class here. What I did here is that instead of allowing giving a blanket approval for all host access, I'm using these annotations. So I can annotate this with host access export, and the code can access this field. So here when I'm creating the context bean, I say that I want to allow only explicit host access. So here name is exposed, author is exposed, ID is not exposed. I actually haven't tried it when I was preparing the demo, so let's do something more exciting that might fail. Let's say book ID. What are we going to do? Just print it. And then we're going to return true. Now I'm really curious if this is going to work. Okay, it works. So it gives us an error that, like if we take a look at, where was it? Here. We should see an exception here telling us that foreign object has no attribute ID. So Python just doesn't see it. So let's see how we can actually expose more things to the Python code, some Java services. So there is this Java book service that has a function or method is a good book. So what is a good book? It's a book that contains Java in its name, right? Because it's Java book service, right? So we are exporting this to Python, and what I'm gonna do here is that I'm going to get the book service bean, and in the context I'm going to get bindings of Python. So that's basically something like a global namespace in Python. So I can put things in there. I can put the Java book service there. Java book service. Right, I need to stop that actually. And run again. And so what I can do now is that I can use the, what was it called? Java book service is good book. Fingers crossed. Yes, we got effective Java, which is non-fiction. Maybe I should have added effective Python and make it a fiction. I don't know. I can make that joke because we are on a JVM conference, right? And here we can see this concept that we're getting this book, which is still a Java object. We're not marshalling it to some Python object. It's still Java object. So what we get back here in the book service implementation is the actual book object. If I took identity hash code, I should get the same one here. It should really be the same object. Actually, we can maybe. I haven't tried it either, so let's have some more fun. Let's say, I don't know. Let's see if that actually works. Yes, I'm doing evil things. Right. Let's get back to the slides. Yes, I wanted to show this Pygal service. Let me just show the code. I won't run it because we don't have enough time. So there's a proof of concept of some kind of integration with the Micronaut framework. For the time being, it actually lives in the application itself in this folder. But eventually, the idea is that this scaffolding, this infrastructure sync would be in a Micronaut extension, maybe. And the usage is this. So I have interface that I call Pygal. I say it's Python bind to a class Pygal. And in my Python sources, which I have in resources, I define a Python class, Pygal class, which happens to implement that Java interface. And this sync here in the Python package is going to do the whole wiring for me. So in the controller, I just say I want to get Pygal injected. And the Micronaut machinery, there is an interceptor and other things. The Micronaut machinery is going to create the bean for me. And the bean will actually delegate to Python, but it will look like just like a Java class for me. So, and I want to stress out that this whole thing works with native image. So if you ever had an issue with native image not being able to execute dynamic code for plugins and things like that, with this, it would work. The plugins would have to be in Python though. So that could be advantage or disadvantage, depends on the point of view. So some more resources. There is a quick reference for GraalPy article that was released just yesterday. A blog post about Truffle Unchained with more details. You can find out there how to run on stock JDK with the GraalVM compiler and other details that I didn't have the time to mention in this talk. Yes, and that's it. Thank you, and let's take a look at questions. Oh, there are some actually. Nice. Is it possible to debug non-JVM languages using GraalVM? Yes. So we support for GraalPy, for example, we support the sort of native Python debugger interface. So it works in the PyCharm IDE. It works with the PDB, which is something like GDB for Python. There was experimental support for debugging Java and the language at the same time, so you can jump from Java to Python. That was integrated in NetBeans, but it's not maintained anymore. But you know, if people told us they really wanted that, then we would be able to do that. Is GraalVM really for free now? No fee per CPU or employee, etc. I'm not a lawyer, sorry. Yeah, I don't feel qualified to answer that question. But I mean, it should be, right? That's the intention. So, like, consult your lawyers or whatever, but it should be. Is there any guarantee for long-term support and maintenance of GraalPy? Not at this point. It's still experimental language in GraalVM, but we would like to change that soon. How resource-intensive is Python context or context in general? It is resource-intensive. I can't give you concrete numbers now, but I mean, you saw it yourself in the examples when we just print hello world from Java, it runs instantaneously. If we add the Python thing, it needs some time to start up and so on. So there is some overhead for that, but I think that's inherent because, well, you're just running another language runtime. Which exactly Python 3 version? It's 3.10. It's going to be 3.12 maybe soonish. So we'll try to sort of keep up with the upstream Python. The thing is that the current release version is, I think, 3.11, and there soon will be 3.12. But lots of the packages actually don't work on these versions. So we actually stick to the latest version, which is kind of supported among Python packages, which happens to be 3.10 at this point. Is GraalPy ready to use for some exciting Django or Flask apps, ready for small scripts? It depends. I would say definitely for small scripts, it works great. It does run Django and Flask. We've tried it and it works. But it will have rough edges. Don't expect to take a large Flask or Django app and just run it without any issues. But if you try, and if you have some success, talk to us, share the results. We are doing this in our labs too. Can I use this with bash scripts? I'm not sure how to interpret that question, but so with GraalPy you can create something that's called virtual environment, Python virtual environment, and you can activate that virtual environment, and from that point in your shell, the Python command will be GraalPy. So you can create a virtual environment with GraalPy, activate it, and then execute a bash script that's calling Python executable, and it will call GraalPy. Yeah, what about Gradle? So throughout the presentation, only Maven is mentioned. What about Gradle? Gradle is supported. I should have mentioned that. My fault. Sorry. Gradle is supported. Any tool that can download things from Maven Central is supported. Any support for ML libraries? We're working on that. It's difficult because those libraries have lots of dependencies. So those libraries are usually native Python packages, so they have lots of native code. The thing is, with the current CPython API, we can't just run it out of the box. We need to recompile the package. So we provide our own header files where some of the functions are defined slightly differently, some of the macros. And so you need to recompile the package. And if you ever try to recompile something like a TensorFlow, you'll find out that it's like you need a non-trivial setup and you need lots of time. So we're working on improving that. But for the time being, if you're curious, give it a go, share the results, but don't expect it to be easy. That's how I would explain that. Seems that all questions are answered now. So thank you for your time.